EGNOS is very useful for operators because it provides GNSS approach with higher accuracy and so that they can fly with lower minima. In case of bad weather, they can fly lower without seeing the runway. And you can also begin an approach with bad visibility. And without EGNOS, you need higher visibility. For example, we flew this morning an approach on the runway 14 right in Toulouse. If you have no EGNOS, you must have 1,400 meters visibility to begin the approach. And with EGNOS, it's nearly half, so a little more than 700 meters. So in some conditions, without EGNOS, you can't fly, you can't land, but with EGNOS, you can. And the same for the decision height, the minimum height, where the pilot must leave the runway to continue the landing. And it's nearly half for with EGNOS than without EGNOS. So in case of bad weather, you can land with EGNOS, and maybe in some cases you should not without EGNOS. So it's very great advantage for the company to bring their passengers where they expect to go.
So today EGNOS is widely used in Europe, and it is equipping already 150 airports, and on these airports about 250 landing procedures are available for airplanes to safely land on these airports.
One of the main tasks of the GSA is indeed to develop the market, to develop the adoption of EGNOS and tomorrow of Galileo. What does it mean in concrete? It means that the GSA liaises by close with the different stakeholders. In this case are airports, air navigation service provider, airlines, in order for them to make the technology updates which are needed to use EGNOS. The civil aviation is a highly ruled environment, since safety is the key factor, and there is a high inertia to change. And so this is where the GSA provides the added value to win this change, to win this inertia, and we do it through different ways. First of all, with extensive dialogue, but as well with the financial instrument. We have a co-financing scheme which help the development of new approach procedure and the update of the avionics which is required on the airplanes.
So we have prepared the flight to go from Toulouse to Pau in the Pyrenees that you can see over there. In Pau we have selected a typical RNAV 31 approach which uses the EGNOS system. The EGNOS system, so I decided to prepare in the FMS the same approach. So Pau, which are the same of the Jepsen chart. At the moment I can cross-check my position, and I see that on my position my mode of navigation, my navigation mode is nav augmented by the bars, so by the EGNOS, and I have a 3 meters accuracy at the moment. And when cleared for the approach, I press the LS button to select the landing system, which provides me with a typical ILS lookalike approach that I can fly in the same way as an ILS, but with the SLS augmented by the EGNOS. And if I compare the minima of the approach, on a standard approach, the minima are 1070 feet, and with the LPV and the EGNOS, my minima are 8,000, so I gain 200 feet lower minima with the EGNOS system. And that basically, with the geometric glide approach, a safety item and a benefit as well in terms of minima.
EGNOS is already providing today very important benefits in terms of safety because there is vertical accuracy and this allows really situational awareness to pilots thanks to this vertical accuracy. And then it's not finished with European GNSS because also Galileo will provide additional robustness and additional availability thanks to its second frequency and being the very important second constellation available to aviation.
Yeah, in Galileo, we are now entering the beginning of Galileo. There are only 2 satellites, so it's not enough to provide the operators with positioning. So, but when all the satellites will be flying, so we can use Galileo system instead of the American GPS satellites. So it will be a little more accuracy will be quite the same, but we could have a better availability and reliability because it's more modern, using some different frequencies. And so in a few years we will see how we can use Galileo.